Look up at the night sky for a moment. Those tiny points of light feel eternal, almost timeless, as if they've always been there and always will be. But hidden behind that calm, steady glow is a surprising truth. Every single star in the universe is slowly heading toward its own ending. Some stars live for millions of years. Others shine for billions. Yet no matter how massive or powerful they are, every star eventually runs out of the energy that keeps it alive. So, what causes these enormous cosmic engines to stop? How can something as powerful as a star, burning brighter than millions of Earths, simply run out of fuel? The answer takes us on a journey from the smallest collisions of atoms inside stellar cores to exploding supernovae that shape entire galaxies, and ultimately to the surprising realization that the atoms inside your own body were once forged in ancient stars. In this video, we'll explore one of the most fascinating cycles in the universe: how stars are born, how they live, and why they must eventually die. Because the death of stars isn't just a cosmic ending, it's the beginning of everything that came after, including us. Out there in the vast darkness of space, stars shine like eternal beacons. Some glow for millions of years, others for billions, lighting up galaxies like cosmic lanterns. To us, they seem permanent, unchanging points in the night sky. But hidden behind that steady glow lies a quiet mystery. Every star will eventually die. Imagine a colossal engine burning brighter than millions of Earths combined. A star produces unimaginable energy every second, flooding space with light and heat. Yet even the most powerful engine must rely on fuel to keep running. And slowly, silently, every star begins using up the fuel that keeps it alive. From our small world, the stars appear timeless. The same constellations watched by ancient civilizations still hang above us tonight. It's easy to assume these distant suns will shine forever. But in reality, each star is moving through a life story billions of years long. Some stars will swell into enormous red giants before fading away. Others will collapse under their own gravity in dramatic cosmic finales. A few will explode with such force that they briefly outshine entire galaxies. These endings may be spectacular, but they all begin with the same simple question: why would something as powerful as a star ever run out of energy? What hidden process determines how long a star can shine? And how can astronomers know that stars truly live and die across the universe? To answer that, we have to start looking at what scientists actually observe in the cosmos. When astronomers point their telescopes toward the night sky, they are not just seeing stars, they are seeing stories unfolding across time. Some stars are just beginning to form inside glowing clouds of gas and dust. Others shine steadily in the middle of their long lives. And scattered across the universe are stars that are clearly reaching their dramatic endings. In vast stellar nurseries called nebulae, new stars are constantly being born. These regions glow softly, like cosmic fog illuminated from within. Inside them, gravity slowly pulls gas together until new stars ignite. It's a bit like watching droplets of water gather in a storm cloud before rain begins to fall. But elsewhere in the cosmos, astronomers witness the opposite moment. They observe stars that suddenly erupt in enormous explosions known as supernovae. For a brief time, a single dying star can shine brighter than an entire galaxy. These brilliant flashes reveal that stellar life does not last forever. Other stars fade more quietly. Some shrink into tiny but incredibly dense objects called white dwarfs. Others collapse even further, becoming neutron stars, city-sized spheres heavier than our sun. Each of these outcomes represents a different ending in the life story of a star. By observing countless stars across many galaxies, astronomers notice something remarkable. Stars seem to follow recognizable patterns of birth, life, and death. Just like living organisms, they pass through predictable stages over time. But the real secret behind these life cycles lies hidden deep inside the heart of a star. To understand why stars live and eventually die, astronomers must look far deeper than the glowing surface we see from Earth. The real action happens in a place no telescope can directly observe: the core of a star. Hidden beneath millions of kilometers of blazing gas, something extraordinary is taking place. Tiny particles are colliding in one of the most powerful processes in the universe. At the center of a star, temperatures soar to millions of degrees. Under this intense heat and pressure, hydrogen atoms are squeezed so tightly that they begin to fuse together. Two light atoms merge into a heavier one, forming helium. In that moment of fusion, a burst of energy is released. It may sound like a small event, just atoms colliding, but imagine trillions upon trillions of these reactions happening every second. It's like billions of microscopic fireworks constantly igniting inside the star. All of that energy pushes outward, creating the light and heat that radiate into space. This process, called nuclear fusion, acts like the star's internal furnace. As long as hydrogen keeps fusing into helium, the star continues to shine. The energy produced pushes outward against the immense pull of gravity, trying to crush the star inward. For most of a star's life, these two forces remain in delicate balance. But fusion also slowly changes the star from within. Each reaction consumes a tiny bit of hydrogen fuel in the core. Over millions or billions of years, that fuel supply begins to shrink. And when the balance inside the star starts to shift, its entire future begins to change, including the fate of the worlds that may orbit it. A star doesn't exist in isolation. Around many stars, entire planetary systems slowly take shape, with worlds orbiting like dancers circling a cosmic fire. These planets depend on the steady energy flowing from their star. The star becomes the central engine that shapes the environment of every world nearby. Think about Earth and the Sun. Our planet's oceans, weather, and even the rhythm of day and night are all tied to the sun's energy. The warmth that melts ice, drives winds, and feeds forests ultimately comes from that distant glowing sphere. Without the sun's steady light, Earth would quickly become a frozen, lifeless world. But stars are not perfectly constant throughout their lives. Over millions and billions of years, their energy output slowly changes. Sometimes they grow brighter, sometimes larger, sometimes less stable. These changes can transform the conditions on the planets orbiting them. Imagine a campfire slowly growing larger and hotter. If you're sitting close, the warmth may become uncomfortable or even dangerous. Something similar happens when certain stars expand late in life. Planets that were once safe distances away may suddenly face intense heat and radiation. In the far future, our own sun will eventually swell into a red giant. Its outer layers may stretch outward far beyond their current boundaries. Mercury and Venus will likely disappear inside the expanding star. Events like these remind astronomers that to understand planetary worlds, they must first understand the life story of the stars themselves, and how scientists manage to uncover those stories from light alone. But here's the fascinating part. Astronomers can't travel to a star, scoop up a sample, and study it in a laboratory. The nearest star is trillions of kilometers away. Yet somehow, scientists can still uncover a star's age, temperature, and even the elements inside it. The secret lies in the light that stars send across space. Starlight may look simple, just a tiny bright point in the sky. But when scientists pass that light through special instruments, it spreads out into a rainbow of colors. This technique, called spectroscopy, works a bit like a cosmic fingerprint scanner. Hidden within that rainbow are thin, dark lines that reveal the star's chemical ingredients. Each element leaves its own unique pattern in the light. Hydrogen, helium, carbon, and iron all absorb specific colors, marking the spectrum like barcodes. By reading those patterns, astronomers can tell what a star is made of. It's as if the star is quietly telling its story through the light it emits. Modern space telescopes take this investigation even further. Observatories floating high above Earth's atmosphere watch distant stars throughout their lifetimes. They capture the brilliant flashes of supernova explosions and the fading glow of dying stars. Every observation adds another piece to the puzzle of stellar evolution. By comparing millions of stars at different stages, scientists can reconstruct an entire stellar life cycle. It's like studying a forest where some trees are seedlings, others are mature, and some are falling apart. Together they reveal the natural rhythm of growth and decay. And behind that rhythm lies a deeper physical rule that determines how long a star can keep shining. At the heart of every star, a silent tug-of-war is constantly taking place. Gravity pulls all the star's matter inward, trying to crush it into a smaller and denser sphere. At the same time, the energy from nuclear fusion pushes outward with tremendous force. A star exists because these two powerful forces balance each other almost perfectly. You can picture it like squeezing a balloon filled with air. Your hands press inward, but the pressure of the air pushes back against them. As long as the pressure inside matches the force from your hands, the balloon keeps its shape. A star works in a surprisingly similar way, only on a cosmic scale. Gravity is always trying to make the star collapse. Meanwhile, the fusion furnace in the core produces energy that pushes outward through the star's layers. This outward pressure prevents gravity from winning the battle. For millions or billions of years, the star remains stable because this balance holds, but there's a catch hidden in that balance. Fusion requires fuel, mainly hydrogen atoms inside the core. Every second, enormous numbers of these atoms fuse into heavier elements. Little by little, the fuel supply begins to shrink. When the hydrogen in the core starts running low, the balance begins to break. The outward pressure from fusion weakens while gravity continues pulling inward. The star's core begins to change, triggering new reactions and dramatic transformations. And these changes don't just affect the star itself. They can shape the future of entire solar systems yet to be born. When some of the largest stars reach the end of their lives, they don't simply fade away quietly. Instead, they collapse inward and rebound in one of the most powerful explosions in the universe, a supernova. In a matter of seconds, the star releases more energy than our sun will produce in its entire lifetime. For a brief moment, the explosion can outshine billions of stars combined. These cosmic explosions scatter enormous clouds of material into space. But this isn't the same simple hydrogen that filled the early universe. Inside massive stars, nuclear reactions forge heavier elements over millions of years. A supernova blasts those newly created elements across the galaxy like seeds in a cosmic storm. Imagine a massive fireworks shell bursting high in the sky. When it explodes, glowing fragments spread outward in all directions. Supernovae behave in a similar way, except the fragments are atoms like carbon, oxygen, silicon, and iron. These elements drift through space and mix with giant clouds of gas and dust. Over time, gravity begins pulling parts of these enriched clouds together again. New stars ignite within them, surrounded by swirling disks of leftover material. Inside those disks, grains of dust stick together and slowly build planets. This is the process that eventually creates entire solar systems. Our own solar system was born from such a cloud about 4.6 billion years ago. The atoms inside Earth, the oceans, and even our bodies were once part of ancient stars. Those long-dead stars exploded, scattering their elements into space, which raises an even deeper realization about the material that makes up our world and life itself. If someone could travel back to the earliest moments of the universe, they would see a surprisingly simple cosmic recipe. In those early times, the universe contained mostly hydrogen and helium. These two light elements formed shortly after the Big Bang, but the ingredients needed for planets and life didn't exist yet. Elements like carbon, oxygen, calcium, and iron had to be created somewhere, and the universe had only one place capable of forging them. Deep inside stars, nuclear fusion slowly built heavier and heavier elements. Stars were acting like enormous cosmic furnaces, shaping the raw materials of the universe. When massive stars died, especially in supernova explosions, those elements were scattered across space. Carbon drifted through interstellar clouds. Oxygen mixed with gas and dust between the stars. Iron, silicon, and many other elements spread throughout young galaxies. Over billions of years, new stars and planets formed from this enriched material. Our solar system formed from one of these clouds filled with the ashes of older stars. The rocks beneath our feet, the air we breathe, and the water in our oceans all carry this ancient history. They are built from atoms forged inside stars long before Earth existed. Even the atoms inside the human body share this origin. The carbon in our cells and the calcium in our bones were created in stellar cores billions of years ago. In a very real sense, every person on Earth carries fragments of ancient stars within them, and when astronomers look beyond our solar system, they see this same cycle shaping entire galaxies. When astronomers zoom out far beyond individual stars, an even larger pattern begins to appear. Entire galaxies behave like vast ecosystems filled with billions of stars at different stages of life. Some are just forming from collapsing clouds of gas. Others are aging quietly, slowly approaching their final transformations. Inside a galaxy, enormous rivers of gas drift between the stars. Over time, gravity gathers parts of these clouds together, forming stellar nurseries. New stars ignite inside them, lighting up the surrounding gas like glowing cosmic lanterns. It's a bit like watching new trees sprout in a forest after rain. Meanwhile, older stars are reaching the ends of their lives. Some fade into dense remnants like white dwarfs or neutron stars. Others explode as supernovae, scattering heavy elements throughout the galaxy. These explosions enrich the surrounding gas, preparing the material for the next generation of stars. Because of this cycle, galaxies slowly change their chemical makeup over billions of years. Early galaxies contained mostly hydrogen and helium, but each generation of stars adds more complex elements into the mix. Gradually, galaxies become richer in the ingredients needed for planets and life. So a galaxy is not just a collection of stars frozen in time. It's a constantly evolving system shaped by stellar birth and death. Each generation of stars leaves behind material that influences the next. And when astronomers trace this process far enough back in time, it leads to the very first stars that ever formed in the universe. To truly understand why stars live and die, astronomers sometimes push their view all the way back to the beginning of the universe. Nearly 13.8 billion years ago, the universe was born in an event known as the Big Bang. In those first moments, space was filled with extremely hot, dense energy. As the universe expanded and cooled, the first simple atoms began to form. At that time, the universe was surprisingly plain. Almost everything was made of hydrogen, with smaller amounts of helium. There were no rocky planets, no oxygen to breathe, and no complex chemistry yet. The cosmos was like a blank canvas waiting for its first structures to appear. Over time, gravity slowly began pulling these clouds of hydrogen and helium together. Regions of gas collapsed inward, becoming denser and hotter. Eventually, the very first stars ignited in the darkness of the young universe. These ancient stars were the pioneers of cosmic transformation. Inside their blazing cores, fusion began forging new elements for the first time in history. The universe had finally gained a way to manufacture heavier atoms. When these early stars eventually died, they scattered those elements into space. Future generations of stars inherited that enriched material. This means every star shining today carries a piece of cosmic history. Their atoms were shaped by earlier stars that lived billions of years ago. The universe has been recycling its material ever since those first stellar pioneers appeared. And when we step back and look at this enormous cycle, it leads to an even deeper reflection about what stellar death truly means. When we first think about the death of a star, it might sound like a cosmic tragedy. A brilliant sun that once illuminated space eventually fades or explodes. Yet in the grand story of the universe, this ending is not simply destruction. It is transformation on a scale almost impossible to imagine. Every dying star releases its material back into the galaxy. Atoms forged under extreme heat and pressure drift through space once more. Over millions of years, those atoms may gather again inside new clouds of gas and dust. And eventually, gravity begins the cycle again. From those clouds, new stars ignite. Around them, planets slowly form from swirling disks of leftover material. Entire solar systems emerge from the recycled remnants of ancient stars. What once belonged to a dying star becomes the foundation of new worlds. Somewhere in that process, one of those worlds may develop oceans, atmospheres, and life. On at least one small planet in the universe, that process produced forests, mountains, and living beings capable of looking back at the stars. The atoms in those living beings were once part of stellar furnaces billions of years ago. In a quiet way, the universe became aware of its own history. So the death of stars is not simply an ending. It is part of a vast cosmic cycle. Matter is continually reshaped, recycled, and reborn across galaxies. The light from ancient stars helped create the elements that formed Earth and everything on it. And when we look up at the night sky, we are seeing both our origins and our future written in the stars.